So let's look now at significant figures. And when we are in physics, we are going to be doing a lot of measurements and calculations. We're going to use a lot of numbers for these calculations. But what we have to be aware of is the significance of those figures, or the Sig Figs, because every measurement, whether we calculate it or take the measurement, has some degree of uncertainty. And we want to try and minimize that uncertainty when we're doing our calculations. Well, let's look at this uncertainty in terms of accuracy and precision. Now, accuracy is how close a measured value is to the correct or accepted value. So if you know how tall you are, how accurate the measuring device would be is how close it gets to that number. Precision refers to how reproducible your measurements are. So how can you get that same value over and over and over again? And the numbers with more digits are considered more precise. So the more digits we have, the more precise our measurement. Let's look at this visually, what we're talking about. So let's imagine a bullseye and we're trying to hit the target. If we were close to the target in a number of hits like this is showing, we are fairly accurate. We'd like to be right on that bullseye, but we've hit the target each time. So we are accurate. Now, precision would be hitting that target at the same spot. It's not hitting the middle, it's not hitting the center, but it is hitting at the same spot. So what we want to try and do in physics or in science is we want both accuracy and precision. We want to hit that target in the center every single time. So we're always going to try and do measurements and calculations with accuracy and precision. So let's first look at measurements. Anytime we are taking a measurement, whatever value we get, the last digit in our measurement is always uncertain. It is our best guess that we can using the measuring device we have. So when we record data, all recorded data is considered significant. However, the last digit is where there is some uncertainty. So if we had a measurement of 1.67 centimeters, it's that last digit that we're not sure about. It is our best guess, but it might be 1.66, it might be 1.68. Our last digit is uncertain, but it is our best guess. Now, if we have a measuring instrument, the instrument generally has a precision of plus or minus 0.5, its smallest division. And we're going to look at this as we do measurements with balances or rulers, etc., that the last digit is really plus or minus 0.5 of that smallest division. We'll look at that in a little more detail in class. So let's look at our rules if we're doing calculations, if we're given numbers, or the rules for significant figures, or sig figs. To determine how many sig figs a number has, and again, we're talking numbers, not measured values, just a number that we're given, we have to follow these 5 rules. First one's pretty straightforward. All non-zero digits are considered significant. So if we have a number 321, all of these numbers are non-zeros. So because there's no zeros in there, this number just has 3 significant figures. That's by far our easiest type to determine the sig figs. Well, if we have zeros that occur between the digits, like in 1001, those zeros, because they are sandwiched in between 2 numbers, are also significant. So 1001 would tell us we have 4 significant figures. Again, pretty straightforward on those rules. The next ones are where it gets a little bit more challenging. In a non-decimal number, zeros to the right of other digits are not significant. That's our rule. What does that mean? First of all, a non-decimal number means that the decimal place is not shown, it's right there. So in a non-decimal number, zeros to the right of other digits are not significant. So we have 2 digits here, 5 and a 2, and we have these 2 zeros that are to the right of other digits. They are just placeholders. They are not significant numbers. The only numbers that would be significant in this are the 2 non-zero numbers, the 5 and the 2. So in an example like this, we would say there are 2 sig figs. The other zeros are just placeholders. Well, what if we have zeros to the left? Same thing applies. Zeros to the left of the first digit are not significant. So if we have a decimal number, again, we have zeros here. We could even consider this 0 in front. These are all just placeholders. That is to tell us that our first significant digit occurs the third decimal place. And the zeros to the left are not significant. All of the other numbers are significant. So once again, we would have 2 sig figs. And this fifth one and last one, in a decimal number, zeros to the right of the last digit are significant. So this is where 4 and 5 are slightly different. We have our decimal place, and we have our two numbers that are shown. We also have these other zeros at the end. Now they're no longer placeholders because this is telling us it's not 0.25, but 0.2500. It is telling us there are 4 decimal places that we have a measurement or a number to. So in this case, those zeros to the right are significant, and we would have 4 sig figs. And using sig figs is something you're going to use in this class and any other science class that involves calculations or measurements. So let's look at some numbers then. So we're going to apply our 5 rules to each of these 6 numbers. So how many significant figures are in each number? Well, our first value, we can see we have a 1 and a 5, and we have zeros to the right of those numbers. Again, those zeros are just placeholders. And in 1500, we have 2 sig figs. Number 2, well, it's our zeros that we're only concerned about. We have zeros sandwiched in between a bunch of numbers. That means all of these values are significant, and we'd have 4 sig figs. Number 3, well, the only zero we have is, again, this placeholder. It is to the left of this first digit. It is just telling us that we are in the decimal values. The only thing significant then would be the 3 and the 4, and we have 2 sig figs. Number 4, very similar to number 3. This time, though, we have 3 zeros that are all placeholders. The first significant digit is that 3, and that tells us we'd have 2 sig figs. What about this big number, 50,000? And despite the fact that the number is big, all of these zeros are just placeholders and insignificant. The only significant digit is that 5, giving us 1 sig fig. And our last example here, we have zeros both before the numbers and after. Now, the significance doesn't start until we get to the 3. And all of those values then are significant, and that gives us 3 sig figs. Now we are going to use sig figs throughout this entire course. So we're going to do this quite a bit. We're going to do a lot more practice in class to determine the number of significant figures in each value.